2.2, some more graphs and displays. So first we talk about stem and leaf plot. Stem and leaf plot, it's a plot, which is it's a graph, and they come with a vertical bar. So from this vertical bar, let's split the data into the stem and the leaf part. Now, with the leaf part, we always keep one digit. We always take the one digit that represent under the leaf part. Stem, it could be one digit, it could be two digits. Depends on the data characteristic you have. If we use the data they provide here, so let's start from 21, 25, 25, right? So when you apply your data into the stem and leaf plot, the first step, we need to sort it. You need to sort your data, put it in the order ranking from the smallest data to the largest data, so that it's easier for you to apply the number into the stem and leaf plot. So when we have the data begin with a 21, so I start from 2, this is 21. The next data is 25, so 2 was here already, I just write down the 5. The third data is 25, 26, 27, 28. And then we build the next level. Begin with the 3 on the stem part. So 30, I put a 0. 36, I put a comma 36. Another 36. And then the next one, we build the next level with the stem as a 4, so 45. So this is a stem and leaf plot. With the stem and leaf plot, we can see the tendency, which is we can see the shape of the graph, we can see the spread of the graph, and we also can find the mode, the median of the graph. With the stem and leaf graph, it's easier. This is when you have the small set of the data, use the stem and leaf graph is helping the audience can easily to approach to visualize the data, because you can see the value of each data. And you also can see the tendency of the graph. So when we have the small set of data, this is a good presentation for you to display your data. We look at another example to construct a stem and leaf plot. The second example has a large size of the data, and all the data here, they are not sorted, right? So we need to put it into the sorted form. And you can use the graphing calculator to sort it, or you can do it by hand, or you can use the Excel to sort it. But when we take the test, normally you will not see the larger size of the data because it's a time taking. So you probably will not see the example like this. Alright, but we still go over this one. With this one, the smallest data we have here is 16. Okay, so 16 is a small number, which is the minimum of the data. And then the large data from the raw data here is 149. So this is the largest size of the data. So the largest data has a 3-digit. The smallest data has 2-digit. How can we apply the different digit number into the same stem plot, a stem leaf plot? So the idea is same way, we draw the vertical bar. This is your stem, and here is the leaf. Right? Remember, the leaf part, we always keep the 1 digit only. So 16, I start from 16, right? So I write down the stem is 6, stem is 1, leaf is 6. And then I record the data by using the order pattern. So 1, on your stem part, they have the number order, increasing order form. So 1, 2, 3, 4, 5. If you look at the graph, the table here, not the table. If you look at the stem and leaf plot example here, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because the large size data is 149. Now with 149, here's a leaf. This is a leaf part, right? We only take the 1 digit, which is with the 14. 149, we split this number into stem that carry the 2 digit, and the leaf carry the 1 digit. So when you have the data come with a larger, it's a little bit larger group, and that comes with a different digit of the number. Normally, we will put a key feature. This is a definition, or it just tell us what does a number, how do they represent for. So the key 102, we put it into the stem plot by separate the 10 and the 2. So 10 is a stem, 2 is a leaf. But when the audience see this example, they will know 10 vertical bar 2, this is equivalent 102 of that data value. So this is stem and leaf plot. Another presentation to perform stem and leaf plot, they have the 2 stem, because especially when you have the raw data, they have a lot of like for example 12, 13, 14, 14, 15, 14, 11, 10, 12, and then they have 17, 18, 17, 19, which is during the one, like a 10 or 20 or 30, those number of the data, you have a long frequency. You have a lot of the data within that 10 interval or 20 interval, because it's too large, too many. So they put it into the 2 stem part, which is the first stem that has a 1. We record a number between 0 to 5. So when you have the data between 0 and 5, they put into the first stem with a 1. And then when you have the data is between 16 and the 19, they put it into the second stem with a 1. But the leaf part, they record after 5, which is 16, 19, 18, 17, 19, when you have the data like that. So for example, if I use the number I put down here, if I want to write it down with the 2 stem plot, so I put a 1 and 1. I write down stem with a 1 2 times here. So the first row with the stem number 1, I record 12, 13, 14, 14, 14. All right, and I didn't sort that, right? Real quick, let me erase it. Okay, let me write down one more time. So we start from 0, 11, 12, 13, 14, 14, 14, and then 15. So here, all the data here let's go to the first stem number with 1. After 15, which is start from 16, the data, they come to the second stem level. So we'll have 17, 18, and the 19. And normally we only take the one stem level, but sometimes when your data, because that's the way it is, when your data has a lot of them, they are doing the 10s, 20, doing the same interval of those number. We go with the 2 stem and leaf plot. So this is the easier way to put your data. It will show a better presentation when people visualize your data. Okay, but normally we go with this one. We only take the one stem on each level. All right, the next one, pie chart. A lot of use, right? Most of people understand very well with a pie chart. Now, pie chart provide a convenient way to present the qualitative data. So far, from a frequency distribution table, from a drive graph, from polygon, we all has the quantitative variable on the horizontal axis, which is the histogram, right? The stem and plot graph, they all present the quantitative variable. When you have the qualitative data, normally they go with the pie chart. Normally, but sometimes they put into the bar graph as well. Right, bar graph, we can represent the qualitative data as well. Bar graph, not a histogram. Histogram only can present quantitative variable. So create a pie chart. A circle is divided into sectors that represent the categories. The area of each sector is a proportion of the frequency of each category, used for summarizing a qualitative variable. So we look at the example here. This is a degree conferred in conferred in 2014. So type of the degree has an associate degree, bachelor, master's, and doctoral degree. So here is a frequency. This is in thousands. So associate degree has 1,003, bachelor is 1,870, master has 700 something, and doctoral degree has only 178. Now, because your data, right, this is your qualitative data, this is a nominal, or we might can say this is an ordinal, right, because it has that order ranking. We know doctoral degree is better than master. Okay, so this data we can count that is more near to ordinal. But if we just distinguish them into the quality, quantity, this would be the qualitative variable. Now, how can we present the qualitative variable into the graph when we go with a pie chart? So first, you need to count how many, what's the total number of those degrees. So when I sum them all together, I get a 3,805. 3,805. That's a total frequency. So now you need to find the relative frequency first, which is a ratio. We take each frequency to divide by total frequency. So as here, you can see the associate degree, the frequency number is 1003. Getting the relative frequency, we use 1003 to divide by total frequency. So this would be the relative frequency is 0.264. Bachelor has a 0.491. Master has 0.198. And the doctoral degree has 0.047. Now, we want to find the area of the sector. Pie chart is a circle. Entire circle has a 360 degree. So in order to define the sector, right, this is a one sector. If this is a sector represent the associate, so we want, this is a portion, it occupies 0.264. So it occupies 0.264 of the entire circle. So finding the sector area of this part, we simply take the 360 degree to multiply the portion, which is your relative frequency. Multiply these two, you get the 95 degree. So that means the sector, the area of this section, it occupies 95 degree throughout the entire circle. So here would be your associate, people getting the associate degree. Bachelor has a 0.491. When you multiply with 360 degree, you get a 177. So 177 is almost half of the circle, right? Half of the circle. So we can draw the sector area almost like a half of the circle. So the red part here represents the bachelor. Master has 71 degree. So 71 degree is less than 90 degree. So we take about something like this. Okay, let me change the color. So here we'll represent the master degree. This is a master. And then the remaining white color here, that represents the doctoral degree. Doctoral degree. Okay. So using the pie chart, number one, you need to add all the frequency number together to get a total frequency. And then you go find the relative frequency. After that, you use the relative frequency to multiply 360 degree. Then you'll get the area of the sector, how much it occupies the entire circle. So this is a pie chart. The last one we call paired data set and the scatter plot. With the scatter plot, it comes with two variables, and those two variables, they are quantitative variable. So it's kind of like X and Y. So each entry is one data set. It's a one data set corresponding to one entry in the second data set. So you have the X and Y value. Now graph using the scatter plot. The older the pair are graphed as a point in the coordinate plane. And we used to show the relationship between the quantitative variable, which is scatter plot. We use the plot. With the plot, it's the idea, right? This is a plot. So this is X value, this is a Y value, which is this is the input, Y value is the output. And we are looking for the association between your X and Y. We want to see whether these two, they have the positive association or negative association. So in here, you will see the horizontal axis and the vertical axis, both of them, they are quantitative data. So far with this graph, you just need to know whether they have the positive direction or negative direction or no relationship between each other. Alright, this is section 2.2. We will talk about more in the class.